Hello and welcome to the StrainSense how-to video series. Today we'll be covering power and efficiency measurement on an electric drivetrain using the Drivetrain W2 PA7 power analyzer and oxygen software supplied by StrainSense. Here is a schematic of an electric drivetrain test cell. Here we see a DC emulator, inverter, motor and load dyno, and the W2 PA7 power analyzer. Here we see the signal inputs to the PA7, DC link voltage and current, three-phase power voltage and current, speed and torque. The PA7 power analyzer has the oxygen data acquisition and analysis software installed on it. I will now show you the data channel setup in Oxygen for the power and efficiency measurement. Here we have a schematic of the PA7 with Trion input modules. First I will show you the Trion power module. This has 4 high voltage 1 kV RMS inputs and 4 current sensor inputs. The module is configured with 3 high voltage and 3 current sensor inputs for the 3-phase power measurement and 1 high voltage and 1 current sensor input for the DC power measurement. Next we have a base module. This has an encoder input used for speed input. And finally we have a low voltage module for a torque sensor input. Those are the inputs that are required for the 3-phase power and efficiency measurement. Next we have the power groups. First we have the 3-phase power group. This has 3 pairs of high voltage and current sensor input with the power group configured in a delta configuration. The power group is synchronized to the first high voltage channel. Within the 3-phase power group we can also configure the mechanical power group. This uses the speed and torque channels configured earlier. This means that the mechanical power calculation is synchronized with the 3-phase power calculation. The output from the 3-phase power groups is the voltage, current, active power, reactive power, apparent power, power factor, energy and mechanical power, and the fundamental frequency for each phase and in total. I will now open up the active power group in the total, and we see that we have active power on each phase and active power in total. In the mechanical power group we have a mechanical power channel and also an efficiency channel based on the mechanical power and 3-phase power. Next we have the DC power group. This has the high voltage DC input and DC current sensor input configured in a single phase power group. Those are the 2 power groups that are required to set up the efficiency calculations in the formula group. We have 3 efficiency channels. We have mechanical efficiency. This is the mechanical power divided by the 3-phase power. This is the efficiency from the motor. Next we have the inverter efficiency. This is the 3-phase power output from the inverter divided by the DC power input to the inverter. And finally we have the total efficiency. This is the mechanical power output from the motor divided by the DC power input to the inverter from the battery emulator. That summarises the efficiency calculations. And finally, we have the snapshot measurement. Using a set point, we can configure the system to measure key parameters at set points during the test. This setup consists of snapshots of speed, torque, mechanical power, mechanical efficiency, inverter efficiency and total efficiency. These are the key parameters required for power and efficiency measurements in the test cell. The power analyzer can be configured for event-based recording. This is ideal for power and efficiency measurements where we're taking snapshot measurements at speed and torque set points. We can use a trigger input, in this case configured as the spacebar, but also it can be an analog or CAN input to trigger the system. The system will then take a snapshot of the parameters we highlighted earlier: speed, torque, power, and the efficiency channels. In addition, the system can be configured to record raw waveform data of the phase voltages and currents for more detailed power electronics analysis post-recording. Thank you for watching our video. This is a video in the StrainSense how-to video series. Please subscribe to our channel to keep informed on the release of our next tutorial. To speak to an engineer, please follow the link on our website and click Contact. We look forward to seeing you next time.